Statistics, one of the most crucial skills needed in the field of data analytics and data science, and even in the field of AI. But do we have enough videos, enough contents on the internet around statistics? Well, if you go and search YouTube and various other platforms, you will definitely find some materials on statistics, but those videos are mostly theoretical. They don't really explain you how these are practically implemented in the field of data analytics or data science. Everybody talks about sampling techniques. Everybody talks about mean, median, mode, or normal distribution, or skewness, kurtosis. But where do we apply it in practicals? Where do we apply it in real world? So I have come up with an end-to-end statistics course. All of my videos that are going to be a part of this video are not published anywhere apart from my official data analytics and data science courses, which means you will not find these videos either on Udemy or on my YouTube channel. This is the first time I'm making all the statistics videos publicly available to you at no cost. So what I've done is I have divided this beautiful end-to-end statistics course into 3 sections. This is the part 1, which is going to be a 2 hours video. I have covered multiple topics in this, and in the following weeks, I will be publishing part 2 and part 3. In the next week, part 2, next to next week, part 3, and combining together, it will be around 6 to 7 hours of contents comprising of multiple topics related to sampling techniques, descriptive analytics, descriptive statistics, inferential, hypothesis testing, types of testing, and so on. Bunch of topics with theoretical knowledge and the code part as well. All the codes will also be given to you. That's it. See you in the video. And if you are liking this video, please like, share, and subscribe to the channel. And do not forget to comment something in this video because that helps me. Also share this video with your friends on LinkedIn, on various other social media, and spread the word. See you in the video. Hi, welcome to this module on statistics. In this video, we shall be talking about the introduction to statistics. What exactly is statistics and how statistics plays a vital role in the field of data analytics and data science? Basically, the statistical analysis is meant to collect and study information available in large quantities. Statistics is simply a branch of mathematics where computation is done over a bulk of data using charts, tables, graphs, etc. For example, you want to analyze 2 numerical columns. Let's say you have data. There are multiple columns in it. There could be name, gender, tenure, age, salary, so many things. Imagine you are analyzing 2 numerical attributes. Numerical attributes are those attributes those have data in format of numbers. For example, age. Let's say age of 10 customers that you have are something like this. Let's say we'll consider 4 examples. Similarly, we also have salary. Let's say the salary at age 25 is this, age 29 is around this, 31 is around this, and 35 is around this. And you start analyzing using some charts. There is a chart called as scatter plot. For example, age goes into the x-axis and salary goes into the y-axis. So let's try to plot each one of them roughly. Let's say we have 5, 10, 15, 20, 25, 30, 35. Around 25, we have 5,000, 10,000, 15,000, 20,000. Now, if I plot this age 25 and 10,000 salary, which is somewhere around here. Age 29 and 12,000 is somewhere around here. Age 31 and 16,000 is somewhere around here. Age 35 and 20,000 is somewhere around here. If I start plotting the graph, this is how the graph looks like, which clearly indicates that there is an increasing trend. That means if age increases, your salary increases as well. This is what the data is telling us using this particular chart. So statistics, as I told you, is nothing but a branch of mathematics where computation is done over a bulk of data using charts, tables, and graphs. The data collected for analysis here is called measurements. Now, if we have to measure the data based on a scenario, a sample is taken out of a population. Population is simply nothing but, imagine if I ask you to find the average age of people in Japan or Indonesia or Malaysia, wherever you are coming from. Let's say, how do you find the average age of people in Japan or in Hong Kong or in China? Now, definitely you are not going to ask each and every one of that country, right? For an example, we'll take an example. I'm not pretty sure about the population of Japan, but imagine the population of Japan is around 40 million. Imagine. Okay. Now, I'm not going to ask each one of them. Now, asking each one of them is going to be, this entire thing is called as population. The entire 40 million. And taking feedbacks, taking outputs, taking statistics from a population is completely a different scenario, and it is not feasible. Usually what we do is we kind of do some sampling out of it. What if I go to different location, I talk to different kind of people, and I take a small chunk, maybe 1000 or 2000 people, and then I ask each one of them what is their age, and then take an average out of it, and just imagine the average age is 39. Now this is the average age of sample, not of the population, right? So this is the difference between population and sample. Definitely there are many and many sampling techniques that we will be covering in the future, based on which you can understand how samples are created in different scenarios. But for the time being, I hope you understand the difference between population and sample. Then analysis or calculation is done for the following measurement. I hope you got an initial idea about statistics. Statistics is very vital for data analytics, and we are going to learn lots and lots of concepts related to statistics in our future videos. In this video, we shall be talking about types of data and statistical analysis. This is how the agenda looks like. We'll get started with the types of statistics, which is descriptive and inferential. Then we'll get started with each one of them. What exactly is descriptive? What exactly is inferential statistics? And lastly, we'll also be talking about the different types of data, which is majorly categorical and numerical, otherwise known as qualitative and quantitative data. See you in the next video. Statistics. In this video, we shall be focusing on descriptive statistics. In the previous video, we learned that statistics is majorly of two types, which is descriptive and inferential. But what exactly is descriptive statistics? Descriptive statistics, as the name says, that means describing. That means descriptive statistics summarizes or describes the characteristics of a data. Imagine you have a data set, and that could be a customer related data. Let's say you have 1000 customers information here. You have age, salary, gender, etc., etc. So many features. The what part is basically nothing but the descriptive statistics. That means, what is the data telling you? What is the average age? What is the total population? What population are males? What population are female? What is the average salary? All this information are nothing but a part of your descriptive statistics. That means the describing the characteristics of a data set. Descriptive statistics consists of three basic categories of measurements: measures of central tendency, measures of variability or spread, and frequency distribution. Measures of central tendency describe the center of the data set, which is mean, median, and mode. What do you mean by each one of them? In short, let me explain you each one of them using some examples. Let's say I have 5 people and the age of these 5 people are 25, 30, 15, 25, 35. Now, what if I ask you what is the average age? We already know what is average. Average is nothing but the sum of all these numbers divided by the total population. This is nothing but the symbol for summation. Now, what is that? This is nothing but 25 plus 30 plus 15 plus 25 plus 35 divided by 5, which is 55, 15, 70, 50, 120, 130 divided by 5, and this becomes 26. So the average age becomes 26. Let me confirm it using a calculator. 25 plus 30 plus 15 plus 25 plus 35 is 130 divided by 5 is 26. Now this is the average. The mean is nothing but the average. Mean is nothing but the statistical name of average. So here the mean is called 26. Mean is also denoted by the symbol mu. What will be median? Median is simply nothing but the middle value. In order to find the middle value, the first thing that you need to do is to sort these values. Let's say if I start writing these numbers from smallest to the largest numbers, first one will be 15, then comes 25, 25, 30 and 35. And the middle value is 25. So this becomes your median. What if you have 6 numbers? Let's say you also have 40. Now you have 6 numbers. 25 cannot be the middle value. The middle value is now 25 and 30 both. So here the median will be the average of these two numbers, which will be 27.5. Mode is something that is usually applicable for categorical data. But in this particular example, the mode will also be 25. Why? Because it has the maximum number of occurrences. Mode is mostly used for categorical data. For example, you have gender. You have 10 customers and or else 5 customers. One of them is male, one of them is female, one of them is empty, one of them is female, one of them is female. Now what if you have data like this? Out of these 5 records, one of these records have a missing value. That means you have to deal with it. Now you can deal it using mode. Here the mode will be female. Why? Female has 3 occurrences, male has 1. So normally mode is nothing but that particular attribute which has the largest amount of occurrences, which has the maximum amount of occurrences. What if you have 2 females and 2 males? In that case, your mode could be both of them. This scenario is called as bimodal. Bimodal. Okay. So anyways, we will be covering measures of central tendency in depth in one of our future videos. Next is going to be measures of variability. Describes the dispersion of the data set, which is variance and standard deviation. Now, what exactly is standard deviation and what is variance? Definitely, we will be understanding in depth in some of our future videos, using mathematical examples as well. In simple terms, if you want to remember what is standard deviation, the formula of standard deviation, which is symbolized as sigma, is nothing but summation. Again, summation is nothing but addition. Summation of xi minus mu square divided by n root over. Now, trust me, do not get panicked using this formula. Do not get panic attack by seeing this formula. This formula will be explained in depth in some of our future videos. The internal part of it without the square root part is nothing but your variance. Okay. Again, theoretically and practically, we will have separate classes for that. And the next part is measures of frequency distribution describe the occurrence of data within the data set, which is called as count. Now, this is a high level idea about descriptive statistics. We have in-depth classes on each of these topics in the future. That's all about this particular video on descriptive statistics. In the next video, we shall be explaining you what is inferential statistics, and then we'll jump into these respective videos. See you in the next video. We shall be talking about inferential statistics. In the previous videos, we understood what exactly is statistics, what are the different types of statistics, which is descriptive and inferential. We somehow got a basic understanding on descriptive part. However, we still have to go through multiple videos on the subtopics of descriptive statistics. But what exactly is inferential statistics? In simple terms, inferential statistics is nothing but a branch of statistics that makes the use of various analytical tools to draw inferences about the population data from the sample data. The two main areas of inferential statistics is estimating parameter and hypothesis testing. Well, a set of method that is used to draw a conclusion about the characteristics of population based on the sample of the data. As we discussed one of the examples, what if I want you to get the average age of an entire country? Let it be Japan, Korea, or any of these countries. Let's say country X. Is it possible to ask each one of them about the age? No, it's not possible. So what we usually do is we infer the same from a sample out of it. For example, we talk to 100 people from different locations of that country, different age groups, different types of people, and then try to understand what each of their ages are. And then we find out, oh, the average age is probably 40. So this average age is definitely not from the population, but from the sample data. So in short, we are inferring that the population, the average age of country X could be 40. That is what we are inferring. And that is all about inferential statistics. A set of method that is used to draw a conclusion about the characteristics of population based on the sample of the data. Used to find the population parameter when you have no initial number to start with. We will be covering these topics in depth. That's all about the basics of inferential statistics. See you in the next video. In this video, we shall be talking about the different types of data. One of the most basic concepts to understand before getting into the future topics. We already know the importance of data. We already know that data is vital for solving a data analytics or a data science problem. But what exactly is data? Data is majorly of two types. One is going to be categorical data and one is going to be numerical data. Categorical data, some of the examples could be, imagine you are analyzing some data. It could be an Excel sheet or something like that. Multiple columns are there. One of these columns are gender. Now gender has values like male, female, and so on. Now this is an example of categorical data because they are in categories. Another example will be location. Let's say multiple customers' location are captured in the data. Somebody stays in Japan, some stays in Korea, some stays in Indonesia, some in Malaysia. So those kind of data are also called as categorical data. Let's say you start analyzing a column which is age, which is having values like 25, 29. It basically has your age of multiple customers or or multiple people. Now these kind of columns are your numerical columns. Now talking about the statistical terminology, we usually term categorical features or categorical variables as qualitative data. Similarly, numericals are termed as quantitative data. Let's try to get into qualitative data. What exactly is qualitative data and what are the further subcategories under it? So qualitative data or categorical data. Qualitative data, also known as categorical data, describes the data that fits into categories. Qualitative data are not numerical, of course. Categorical information involves categorical variables that describe the features such as a person's gender, hometown, etc. Gender could be male, female, hometown could be any country, Indonesia, Malaysia, Japan, whatever it is. These are all your categorical or qualitative data. Sometimes categorical data can hold numerical values as well, but those values do not have a mathematical sense. For example, examples of the categorical data are birth date. Now, what if somebody's birth date is something like this? Now, these are combination of numerical values. These are all your numbers, but it is termed as a categorical data, not as a numerical data. We also have favorite sport, school postcode. Here the birth date and school postcode hold the quantitative values like this. They have numbers in it, but they don't give any numerical meaning. There is no numerical meaning to it. So these kind of data are considered as qualitative data, even though they have quantitative values, right? So inside qualitative data, majorly there are two types of data. So data, as I told you, data is of two types, your qualitative and your quantitative. Inside qualitative comes your nominal and ordinal data. Nominal data is one of the types of qualitative information which helps to label the variables without providing the numerical value. Nominal data is also called the nominal scale. It cannot be ordered and measured. This is the most important feature of nominal data, that it cannot be ordered. But sometimes the data can be qualitative and quantitative. Examples of nominal data are letters, symbols, words, gender. Now, for example, we consider gender, male and female. We cannot order it. We cannot say males are superior than females or vice versa. So there is no ordering. Okay. So the nominal data are examined using the grouping method. In this method, the data are grouped into categories and then the frequency or the percentage of the data can be calculated. These data are visually represented using pie charts. For example, you start analyzing gender. A better chart will be a pie chart, something like this. let's say female and male, let's say 45% and 65%. Sorry, 45% and 55%. My bad. 55%. They could also be represented in a bar chart. Male, female and male. So something like that, right? Now, of course, in this example, male are 55%, so they should look like this. But I'm just giving examples, right? That they can be represented visually using pie charts, using bar charts, and so on. Now, moving towards the ordinal data. Of course, as the name suggests, ordinal has something to do with orders or ordering. The significant feature of ordinal data is that they can be ordered. The first and foremost feature of ordinal data. Ordinal data, sometimes categorical data, can hold numerical values as we already discussed, but those values do not have a mathematical sense, right? We already discussed this. Ordinal data are some of these variables which are used mostly in surveys, finance, economics, questionnaires, and so on. What are some of the examples of ordinal data? One example is economic status. Economic status could be high, it could be mid, it could be low, and we already know it's in an order, right? It starts from low to high, right? Or else, let's say you are analyzing students' grading system. Some people have got A, some people have got B, some people have got C, some have got D, and we already know that it's in an order. So these kind of data are called as ordinal data. How do we represent it visually? Ordinal data is commonly represented using a bar chart. These data are investigated and interpreted through many visualization tools. Let's say you start plotting the graphs for economic status, high, low, and medium, right? So these kind of graphs can give you insights that, majority of the people are falling in this category. Low number of people are falling into the low category, like less number of people, right? And so on. So bar chart is going to be a to-go visualization kind of technique to plot and visualize and analyze the ordinal data. The information may be expressed using tables in which each row in the table shows the distinct category. So that's all about your basics of types of data and the qualitative data. We also discussed about nominal and ordinal data. In this video, we shall be talking about quantitative data. In the last video, we talked about the different types of data in which we discussed about qualitative and quantitative. In this video, we shall be focusing more on the quantitative type of data. What do you mean by quantitative? Simply, quantitative data is also known as numerical data, which represents the numerical value. That is, how much, how often, how many. Numerical data gives information about the quantiles of a specific thing. Some examples of numerical data are height, length, size, weight, and so on. The quantitative data can be classified into two different types of categories. The two major classifications of numerical data are discrete data and continuous data. What exactly is discrete data? Discrete data can take only discrete values. If you have quantitative data, like number of workers in a company, let's say we are talking about a company X. So, for example, you have quantitative data like a number of workers in a company. Could you divide every one of the workers into two parts? It's not possible because the number of workers is discrete data. So let's try to define discrete data in a better way. Discrete data is a count that involves integers. Only a limited number of values is possible. For example, the number of students in a class. The number of students in a class could be 40, could be 45, could be 50. It cannot be 40.5. It cannot be 39.5. It cannot have these numbers. So discrete data can take only certain values. The data variables cannot be divided into smaller parts. How do we plot discrete data? We can plot using any kind of graphs. It could be a pie chart, or it could be a stem and a leaf plot. It could be anything. Going forward, some other examples of discrete type of data could be, apart from number of students in a class, it could be number of workers in a company, number of languages an individual speaks. For example, I speak 6 different languages. One cannot simply speak 4.5 languages or 3.5 languages. It's not possible. So these type of data are called as discrete data. Now what is continuous data? Continuous data is data that can be calculated. It has an infinite number of probable values that can be selected within a given range. Now, for example, you can measure your height at very precise scales. It could be meters. Let's say my height in meter is 171 meters. In centimeters, it is 171 centimeters. In feet and inches, it is 5 feet 8 inches. So you can measure your height at very precise scales. You can record continuous data at so many different measurements: width, temperature, time, and etc. This is where the key difference with discrete data lies. So this is the example of a continuous data, and I hope everybody is clear with the difference between discrete and continuous data. That's all about this video on quantitative data. Hi, welcome to this module on statistics. In this video, we shall be talking about sampling techniques. This is how the agenda looks like for our next few videos. It all starts with population and samples. We'll talk about population and samples. What exactly is population? Population simply is nothing but the entire group that you want to draw conclusions about. And sample is the specific group that you will collect data from. The size of the sample is always less than the total size of a population. For an example, if somebody asks you to find the average age of the entire population of Japan, now it's not possible to talk to each and every person from Japan about their age. Rather, we'll start working on a smaller chunk of data, start capturing data, and then find, oh, the average age is probably around 40. So this is the difference between population and samples, which we will be covering in depth. Next, we shall be discussing about the types of sampling technique. There are so many types of sampling technique. We will be discussing them: random sampling, non-probability sampling, population sampling, and so on. We will be, in short, studying about various sampling techniques, population, samples, and all these related topics in the next few videos. See you in the next video. We shall be talking about population and sample. What exactly is population and what is sample? The simplest definition of population is nothing but the entire group that you want to draw conclusions about. The universe of objects that is required to be analyzed is known as population. And sample is nothing but a subset of population. It's a part of population. It is the specific group that you will collect data from. The size of the sample is always less than the total size of population. In research, a population doesn't always refer to people. It can mean a group containing elements of anything you want to study, such as objects, events, organizations, countries, species, organisms, etc. Now, some of the examples of population. What if, as I was giving this example in the last video, what if somebody asks you that what is the average age of a particular country? It could be any country. It could be Japan, Korea, India, Philippines. It could be any country. Imagine a country X. If somebody asks you, can you find the average age of a country? No. It is it is completely impossible to do it. You cannot simply go and talk to each one of them, ask their age. The moment you probably go from one individual to another individual, already be, a lot of time will be invested in this process. So it is logically not possible to interact with each one of them, get a list of all their ages, and then find their mean value or the average value, right? Instead of that, what you should do is you should divide your country into specific areas. Let's say, what if you divide your countries into four particular sections, or else could be north, could be west, could be east, could be south, and could be central. Or you can divide it as per your own wish. Again, as per your divisions, how about you go and talk to a small chunk of data, probably 10, 15 people from each chunk, and then you take around 100 or 200 samples and then ask what is their average age, and then probably you find it out that the average age is around 40. Now this is what the average age is from the sample data. So that's how the difference between population and sample looks like on paper. In logical sense, in real world scenarios, we never work on population data. Whenever you start working on a data analysis problem, we always starts with a sample data. Once our sample data is created, once we start analyzing it, then we move towards the population data. Like theoretically, it's not possible to work on the entire population, but we usually work on sample data. I hope you understand the concepts between population and sample. This video we shall be talking about why sampling is important. We already know what exactly is a sample and what is a population data. So population is nothing but your entire thing. Let's say you are analyzing the people of Japan or people of Korea, which could be in millions. I'm pretty much not sure about the population of Japan. Now, what if you have to analyze them or you want to find something, the average age of a person in Japan? Obviously, you cannot go to each one of them and ask about it, right? So, you always have to work on samples. You always have to work on samples because of this reason. You cannot simply go ahead and talk to the entire population. But what you can do is you can probably got to go and talk to different categories of people in Japan, probably 100, 200 people, and then start collecting information and then come to a conclusion that, oh, the average age from this sample is 40. So we can also infer that the average age of the population, entire population in Japan, could be 40. That is the advantage of sampling, right? Gathering data from entire population is not possible. Sampling is applicable in such situation where gathering data from entire population is not possible. Using sampling, one can make information faster. Surveying and measuring everyone is not cost effective. We can easily analyze the data when using the sample of the data. Imagine you have a data worth gigabytes of data. It could be like 100 gigabytes of data. And somebody has asked you to start analyzing and creating some dashboard, some visualization dashboard, or some sort of graphs, right? Now, obviously, if you get started with 100 GB of data, if your computer is not fast enough, probably you might take a lot of time in analyzing the data and then a lot of time in visualizing it because it could be slow. right? So a better approach here will be kind of creating a sample data, probably of some MBs, maybe 500 MB or 200 MB, and then get started with your analysis and your visualization process. Once this is done, and then you can go ahead and change it to the population data. It's possible, right? So it is usually an easier step to analyze a sample data. A smaller set of individuals often results in lesser data collection error. Again, when you are working on small chunk of data, you might have to deal with less data collection issues as compared to population data, right? So these are some of the advantages of why sampling is important. Hi, in this video we shall be discussing about the different types of sampling techniques. So far, I hope everybody understood the concepts behind the population and sample. We also know why sampling is important. Now, the next question is, how do we sample? How do we create samples? What are the different sampling techniques? So, sampling techniques are majorly of two types. One is probability and one is non-probability sampling. Probability sampling basically means every member of the population has an equal chance of being selected. Imagine you have an entire population. You want to select some samples out of it. Let's say these are my entire population, and maybe this data and this data are part of my sample. Now here, selection of a data point from population to the sample is a probabilistic approach. There are further many types of probability sampling. One of them is simple random sampling, stratified sampling, cluster sampling, systematic sampling. What are each one of them we will be covering in the next videos. But the major concept behind this probability sampling is that they are based on probability. Every member of the population has an equal chance of being selected in the sample data. While talking about non-probability sampling, here samples are selected on basis of judgment or the convenience of accessing data. Now, for example, you have a population, you want to only access the data points, or for example, let's say this is your entire population. Let's say you stay in Japan. Now, you only want to, for example, you stay in Tokyo. What if you only want to access the Tokyo population, and then from that you have to select a smaller subset, and then you are selecting a sample? So here you are selecting based on your convenience. As you stay in Tokyo, it is better for you to talk to people from Tokyo and take views, and that's how you are creating your sample. You are not concerned about other cities in Japan. So that is non-probability sampling. What is the probability of another city's data to be a part of sample? It is completely zero because the user is giving priority to Tokyo. I hope you are getting my point. So samples are selected on basis of judgment or convenience of accessing data. Largely depends on a research sample selection skills. Some of the non-probability sampling are convenience sampling, purposive sampling, voluntary response sampling, and snowball sampling. We'll be discussing about each one of them in our future videos as well. We discussed about what exactly is a probability sampling and what is a non-probability sampling. We also kind of talked about the various probability sampling techniques, which is random, systematic, stratified, and cluster. Similarly, we also talked about the various non-probability sampling, which is convenience sampling, purposive, voluntary response, and snowball. This video is dedicatedly going to be on probability sampling. We will be talking about each one of them in this video. So let's get started. Talking about random sampling. Random sampling is simply a type of sampling where you randomly choose a member from population. Imagine this particular example of population. We have person 1, 2, 3, 4 till 12. Now, randomly you select 4 records from this particular population. It could be this. It it could be this. It could be any random samples. It could be any random element from your population. This is simply called as random sampling. Every member and set of member has an equal chance of being selected. Now the probability of getting selected for this person in the sample and the probability of this person to be selected in the sample is same. And that is one of the reasons why it is considered as one of the probabilistic approach, one of the probability sampling technique. Secondly, we will discuss about systematic sampling. Now again you see this population 1 to 12, but here what if you select the every third guy? Imagine the first cursor is on the second person and then you select every third guy. That means 5, 8 and 11. What if you select all the persons who is at the odd location? Maybe 1, 3, 5, 7, 9, 11. So this becomes a sample. This type of systematic sampling is called as, this type of systematic way of selecting samples is called as systematic sampling. This is also called as systematic random sampling. It is very similar to simple random sampling, but in a systematic manner. Put a member of the population in some order and a starting point is chosen as random. The every nth member is selected to be in the sample. After systematic sampling comes stratified sampling. Now, this is one of the most important sampling techniques. Now, what it tells you is that first of all, we have to divide the population into groups. Imagine, I'll give you an example. I have a population of 1000 records. What if I want to create a sample of 100 records? If I talk about simple random, that means randomly I take 100 records. If I talk about systematic random, that means systematically I pick every 10th element, or else from 1 till 1000 I pick every 10th element, 1, then 11, then 21, then 31 and so on. Is this the right way of creating a sample? Probably not. What if in my 1000 records, imagine I have 1000 records and in that let's say I have a combination of male and a female. Let's say male are 600 and female are 400. If you randomly select a sample of 100 records, I cannot guarantee that it will also have the male is to female in the same ratio of 600 is to 400. I cannot guarantee that it will follow the same ratio. I cannot guarantee in simple random sampling. I cannot guarantee in the systematic random sampling as well. So what stratified sampling tells you is that if you have different kinds of population like this, different groups, how about you choose 60 random data points from male and 60 random data points from female and then create your sample data. Now in your sample data, you can see the male is to female ratio is same as the total population data. That means your group distribution is maintained. So the explanation goes like this. First divide the population into groups, then from each group we select members randomly by maintaining the ratio. That is called as stratified sampling, and it is one of the most important type of sampling, right? Because you should always maintain the original distribution, right? After the stratified sampling comes cluster random sampling. What do you mean by cluster random sampling? As the name suggests, we have to create some sort of clusters, and then probably from these clusters we have to randomly pick some data points, right? You can see divide the population into groups, then randomly select the group from all the groups. Imagine again I have 1,000 customers, and let's say you are working on a segmentation problem. You want to segment your customers into different groups. How many groups you don't know. So probably what you do is you use a clustering technique. So clustering technique is one of the advanced techniques which is covered under machine learning. A clustering technique simply means the way you create clusters. For example, if you divide 1,000 records into multiple clusters, it could have 3 clusters, it could have 5 clusters. Cluster basically means all the customers, all the people inside this cluster are similar in nature. All the people inside this cluster are similar in nature. All the customers are in this cluster are similar in nature. Similar in nature and similar in nature. And then you randomly pick some records, maybe 600 from here, sorry, not 600, 60 from here, 30 from here, 5 from here, 3 from here, 2 from here, and then becomes your 100 samples. This type of sampling is called as cluster random sampling. So you have to create clusters, and then from the clusters you have to pick samples. That's all about this particular video on probability sampling techniques. I hope you understood each one of them. Practically, we'll try to go through each one of them probably in some of our future videos, where we will show you how to create samples and all those things. In this video, that's it. In the next video, we shall be talking about the non-probability sampling techniques. See you. In this video, we shall be talking about the non-probability sampling. Well, in the last video, we discussed about the probability-based sampling. Selection of a sample from a population is based on a probability value. This data point being a part of sample, or this data point being a part of sample, the probability remains the same. That kind of sampling is called as probability sampling. In case you are not aware of this concept, please go back to the previous video and get your doubts clarified. In this video, we shall be discussing about the non-probability sampling techniques. The first technique is convenience sampling. What exactly is convenience sampling? A convenience sampling simply includes the individuals who happens to be most accessible to the researcher. Imagine you have your data communities, probably on WhatsApp groups or Telegram groups, and you quickly need to fill up a survey form. What you do is you quickly send your survey links in various WhatsApp groups. That means based on your convenience, you want people to fill the records. That type of sampling is called as convenience sampling. For example, you are researching opinions about student support services in your university. So after each of your classes, you ask your fellow students to complete a survey on the topic. This is a convenient way to gather data. But as you only surveyed students taking the same classes as you are at the same level, the sample is not representative of all the students in your university. That type of sampling is convenience sampling. Next is purposive sampling. Purposive sampling means selecting a sample based on the purpose of the research. Researcher selects the sample by using their expertise and knowledge. Example, you want to know more about the opinions and experiences of disabled students in your university. You have your university, and there is a small chunk of people who are having disabilities, some disabled students. So you purposefully select a number of students with different support needs in order to gather a varied range of data on their experiences with student services. So purposely you are selecting this group of people to take some feedbacks. This type of sampling is purposive sampling. The next type is voluntary response sampling. Similar to convenience sampling. A voluntary response sampling is mainly based on ease of access. Instead of the researcher choosing participants and directly contacting them, people volunteer themselves. Example, by responding to a public online survey. Let's say you have an online survey and people are responding to it. One easiest example of voluntary response sampling is LinkedIn polls. If you are creating a post on LinkedIn and you are having a poll whether data analytics is the best domain or data science, and people start voting on them, that's kind of a voluntary response sampling. Next comes snowball sampling. If the population is hard to access, snowball sampling can be used to recruit participants via other participants. It is used where it is hard to find the potential population for research. For an example, you are researching experiences of homelessness in your city. You are working in a city, let's say Tokyo or Jakarta or any kind of cities you are from, and you are kind of researching experiences of homelessness in your city. Since there is no list of all homeless people in the city, probability sampling isn't possible. So you meet one person who agrees to participate in the research, and she puts you in contact with other homeless people she knows in the area. For example, you meet Mr. X and you talk to him or her that, hey, you know what, I want to talk to more homeless people in order to get some survey data. Now she gets in touch with you and she basically recommends you that I know some sort of people, homeless people who can help you out. So this kind of sampling technique is called as snowball sampling. That's all about the various non-probability sampling with examples. I'm pretty much sure that you now have a basic understanding on these topics. That's all about this video. See you in the next video. In this video, we shall be talking about the population sampling. What do you mean by population sampling? Analyzing or testing entire population is impossible and also a cost and time taking process. To save our money and time, we use the subset of the entire population called a sample. Population sampling is the process of selecting a subset of the objects that is representative of the entire population. The sample must have sufficient size of objects to warrant statistical analysis. Must be performed correctly since errors can lead to inaccurate and misleading result. Now this particular table will give you an initial idea about the mathematics behind it. You can see the first column, which is population or sample. The first category is population and the second category is the sample. There are various terms inside population: population size, population mean, and population variance. Similarly, we have sample size, sample mean, and sample variance. Now, before talking about variance, let's talk about standard deviation. Standard deviation. Well, I will have a detailed class on standard deviation in one of our future modules, in one of our future classes. But standard deviation simply means it's a measure of how spread out numbers are. It is usually symbolized with this, which is called as sigma, the Greek letter sigma. The formula of standard deviation is very simple. Standard deviation is nothing but the square root of variance. But what is variance? Variance is nothing but it is defined as the average of squared differences from the mean. Now, if you talk about this formula, variance is simply summation of xi minus mu square divided by n, where summation simply means the combination, the addition of all the values. Xi means the original data point, and this symbol, which is called as mu, is nothing but your mean value, or in simple terms is called as average. So variance formula is this. It is the summation of xi minus mu square divided by n. That's all about variance. Size basically means the number of items or elements in the population, and mean is the average value. If you closely look at the formula of population variance and sample variance, there is a minute difference in the denominator. In population, in the denominator we have n, but in sample we have n minus 1. The reason behind this will be explained in one of our future videos, but as of now, just remember this thing. Population variance is something like summation of xi minus mu square by n. If you have 100 records in your population, this n becomes 100. If there are 10 records in your sample out of population, then the variance becomes xi minus mu square by 10 minus 1, which will be 9. Okay. So that's all about this particular slide on population sampling. Well, I'll try to quickly explain a small example using the mathematical formulas. Let's say I have few records 5, 10, 15 and 20. What is the addition of these numbers? The addition of these numbers are, let's say one more, 30. 5, 10, 15, 20, 30. If I sum it up, it becomes 50, 55, 65. So it becomes 5 plus 10, 15 plus 15, 30, 80. So it becomes 80. Now 80 divided by 5, what will be the average value? It will be 16. Now what will be xi minus mean? For the first record, it will be minus 11. For the second record, minus 6. Third record, minus 1. Fourth record, 4. Fifth record, 14. What will be xi minus mu square? So this becomes 121. This becomes 36. This becomes 1. This becomes 16. And 14 square becomes, I think, 196. I hope everybody knows that the square of a negative number is always a positive number, right? So this becomes my xi minus mu square for each of these entities. What will be the sum of these values? So the sum of xi minus mu square will be 121 plus 36 plus 1 plus 16 plus 196. If you add it up, 196 plus 16 plus 1 plus 36 plus 121 becomes 370. Becomes 370. So if these 5 records are part of my population, then the variance becomes summation of xi minus mu square divided by 5 root over. This becomes, sorry, not root over. If it is root over, this becomes a standard deviation. Let me write it down, standard deviation. Okay, which becomes 370 by 5 root over, which becomes 370 by 5 is simply 74. So 74 is my variance, and my standard deviation is the root over of 74, which is somewhere around 8 point something, 8.6. This becomes your standard deviation. Now, if these 5 records are a part of your sample data, not a part of your population data, in that case, the standard deviation formula becomes 370 divided by 4 root over. So 370 by 4 is around 92.5. Root over will be, sorry, 92.5. Root over is 9.6. 92.5 root over is 9.6. So here the variance becomes 92.5. The standard deviation becomes 9.6. So that's the mathematical way of understanding different concepts. Well, the why part is still not clear, but hold on, we have a separate video for that. That's all about this particular video on population sampling. And trust me, the mathematics and the all this kind of calculations part is going to be even simpler and simpler in our future videos as well. I'll try to simplify as much as possible. So that's it about this particular video. See you in the next video. In this video, we shall be talking about why do we have n-1 for the sample data and n for the population data. So far, we already understood the formula of variance and standard deviation. Variance, which is nothing but standard deviation square, is nothing but summation of x minus mu square divided by n. Now, this exact formula changes for the sample data. In case of sample data, the variance is nothing but summation of x minus mu square divided by n minus 1. Now, why do we have this n minus 1 for sample data and n for this population data? Well, there is a theory behind it. We have to take a small example and try to understand why do we have this. This is basically called as Bessel's correction. This method corrects the bias in the estimation of the population variance. It also partially corrects the bias in the estimation of the population standard deviation. The idea behind this is that this is a more unbiased measure of variance than the usual definition. Let's try to take a small example and try to understand why n-1 for sample and why n for population. Imagine you have a book shelf. Let's say the total thickness of the first 6 books. Imagine you have 6 books. Turns out to be 158 mm. So let's say here we have 158 mm as the total thickness, which definitely means the mean will be 158 divided by 6, which will be 26.3. That's my mean thickness. Now you take out and measure the first book's thickness, which is called as 1 degree of freedom, and that is 22 mm. Let's say the first book thickness was, let's say, 22 mm. Now you have 5 books. What is the total thickness of 5 books? It is 158 minus 22, which is 136 mm. Now we have 5 books. Now you measure the second book, which is second degree of freedom, and find it to be 28 mm. Let's say the second book is 28 mm. Now here, what will be the total thickness left? 136 minus 28, which will be 108 mm. And now you have 4 books. And the same process goes on. In this way, by the time you measure the thickness of the 5th book individually, which is here you are selecting the 5th book. When you are doing that, which is the 5th degree of freedom, you automatically know the thickness of the remaining 1 book. Let's try to take examples. Now, here we have 4 books and 108 mm. Let's say the third book is like 30 mm. Now here, the total width will be 78 mm and we have 3 books. Then the 4th book, let's say, is 25 mm. So here, the left out will be 53 mm and we have 2 books. Imagine at this point of time where you have 2 books, the total thickness is 53 mm. Here you are picking the 5th book, and let's say the 5th book, which is called as the 5th degree of freedom, is found to be, let's say, 20 mm. When you find the thickness of the fifth book, it is quite understood that the sixth book, the final book's thickness is going to be this minus this, which will be 33 mm. So you don't have to know about this final book. You are easily getting the final book's thickness when you are picking the fifth book. That means you automatically know the thickness of the sixth book even though you have measured only 5. Extrapolating this concept in a sample of size n, you know the value of the nth observation, even though you have only taken n minus 1 measurements. That is, the opportunity to vary has been taken away for the nth observation. And exactly this is one of the reasons why we do not consider n in terms of sample data. So in sample data, we consider n minus 1. That's all about this particular video about why n minus 1 for sample data and why not n. And see you in the next video. Bye-bye. Hi, welcome to this module on statistics and this chapter on descriptive analytics and statistics. In this particular chapter, we are going to cover everything related to the descriptive part. There are majorly two concepts which is studied inside the descriptive statistics. One of them being measures of central tendency and one of them being measures of dispersion. Now these two topics are going to be the most important topics under descriptive, and we will be doing a deep dive analysis on these kind of topics. Under central tendency, we'll try to understand the concepts like mean, median and mode. And under dispersion, there will be concepts like range, interquartile range, variance, standard deviation, mean deviation, and so on. Each and every topic is going to be covered in details. And in this video, we shall be focusing on measures of central tendency. So far, we already know that statistics is of two types. One is your descriptive and another is your inferential. And inside descriptive comes this topic called as measures of central tendency. What exactly is measures of central tendency? As you can see, it measures the center value of the dataset. It gives us the idea about the concentration of the value in the central part of the distribution. In simple terms, a measure of central tendency is a single value that attempts to describe a set of data by identifying the central position within the set of data. As such, the measure of central tendency is also called as measure of central location. They are also classed as summary statistics. The mean, often called as average, is the most likely measure of central tendency that we are most familiar with. We all know what exactly is mean, what is an average, right? Apart from mean, there are others as well, which includes median and mode. The mean, median and mode are all valid measures of central tendency. But under different conditions, some measures of central tendency become more appropriate to use than others. Now, what exactly is the usage of these topics? Why are we discussing these things? First of all, let's try to understand that each one of them is a central tendency, is a measure of central tendency, which gives us an idea about the central part of the distribution. Going forward, we have separate slides on mean, median and mode, where you will understand that using examples, we'll try to understand which type of concept is going to be used in which type of scenarios. So that's all about this particular video on the basics of measures of central tendency. Going forward, we have dedicated videos on mean, median and mode. That's about it. See you in the next video. Mean is nothing but the statistical definition or statistical term that we use instead of average. What exactly is average? We all know what is average. an average set of observation of the data. It computes the sum of all observation present in the datasets divided by the total number of observation. For an example, you have three numbers 1, 2 and 3. What will be the sum of these numbers? The sum will be 6. What will be the average of these numbers? The average will be 6 divided by 3, which becomes 2. Now this is nothing but your mean. So mean or average is nothing but add or sum each number or observation present in the dataset, calculate the total number present in the dataset, divide sum of observation to the total number of observation. Using mathematical formulas, which looks really complicated, this is nothing but this x bar is nothing but your mean value. Mean value is nothing but sum of all x divided by n. This symbol is called as summation, which is nothing but sum of all numbers. So if you are passing x here, that means 1 plus 2 plus 3, which is 6. So in the numerator becomes 6 divided by how many entities? We have 1, 2 and 3, 3 numbers. So here the average becomes 2. So mean or average is the most popular and well-known measure of central tendency. It can be used with both discrete and continuous data, although its use is most often with continuous data. The mean is equal to the sum of all the values in the dataset divided by the number of values in the dataset. So if we have n values, in that case, and the values are x1, x2, x3 xn. So here the mean value will nothing but x1 plus x2 plus xn divided by n. And this is nothing but this particular formula. Okay. So summation of x divided by n. Now, when do we use mean? And why do we use mean? Where is the scenario where we start using this mean? Imagine a data set. Let's say you have a column called as age. You have a data. Let me just rub this off. You have you have a data set. And imagine one of the columns is age. And as you have captured the data, some of the records are null. Let's say one of these ages is 25, 29, null, 31, 25. So out of 5 members, one of them is a null record. Now, in your data analysis, while you prepare your data, handling missing values is one of the critical tasks that we handle. Because if you don't handle the missing values, your analysis could be, you could go in a wrong direction of your analysis. So it is usually recommended to deal with your missing values, which we will be covering in depth in the future classes while we talk about the exploratory data analysis. But what is the right way of imputing this value? One of the most idiotic approach is randomly impute it with some random numbers. Let's say impute it with 30. Is this a right approach? No. What is a better approach? A better approach is imputing using mean or median. So if you impute using mean here, what will be the mean here? 25 plus 29 plus 31 plus 25 divided by 4, which will be 25 plus 29, which is 54, plus 31 plus 25 should be 110 divided by 4, which is 27.5. Now, as this column is age, can somebody's age be 27.5? Well, logically it could be 27 years and 6 months. But as everything is a whole number without any decimals, probably we will use a rounded number here, which is 28. So 28 becomes my imputed values that we are imputing in the missing values. This is one of the applications of mean. That's all about this particular video on mean. I hope you understood what is mean, what is average. In the next video, we shall be talking about median, mode, and various other topics. See you in the next video. In this video, we shall be talking about the second type of measures of central tendency, which is median. In simple terms, median is nothing but your middle number. That means the center number, found by ordering all data points and picking out the one in the middle. If there are two middle numbers, taking the mean of those two numbers will give you the median value. Mathematically speaking, there are two possibilities. If you have a set of numbers, you could have odd numbers or you could have even numbers. What do you mean by odd numbers? Let's say you have 5 numbers in this list. That means you have odd numbers. Now, if you have odd numbers, it is easily understood that the middle value is going to be the third number. But what if you have 6 numbers? Because in 6 numbers, you have 1, 2, 3, 4, 5, 6. Here there are 2 middle numbers. Now in this case, what happens is you have to take the average of these two. So mathematically speaking, the number of observations is odd. In that case, the median is the middle value, which is at position n plus 1 by 2. In case of even numbers, the median is the average of two middle values. Find the value at position n by 2 and then find the position at n by 2 plus 1 and then try to find the average. Well, sounds little bit tricky from the theoretical concepts point of view. Let's try to understand using an example. Let's say I have an example. Again, I have age. I have 25, 31, 27, 23, 33, 32. Now, how to find the median of these 6 numbers? How to find the mean of these 6 numbers? It is simple. Summation of all the numbers divided by n. Right? Which means it will be 25 plus 31 plus 27 plus 23 plus 33 plus 32 divided by 6, which is 28.5. This is your mean value. How to find the median? First of all, to find median, you have to order them. That means you have to sort them. Let's try to sort them. 23 comes first, then comes 25, then comes 27, then comes 31, then comes 32, then comes 33. As there are 6 numbers and it falls into this category, first we have to find n minus n by 2, which is the third value. 6 by 2 is third, this value. What will be n by 2 plus 1? It will be this value. Now we have to take an average of these two. So the average of these two will be 58 by 2, which will be 29. So 29 becomes your median. Imagine you have another number here. Let's say 19. Now if you sort it, 19 comes here. 1, 2, 3, 4, 5, 6, 7. Out of 7, we have to find n plus 1 by 2, which is 7 plus 1 by 2, which is the fourth location, which is 1, 2, 3 and 4. So this becomes my median when you have odd numbers. So this is the concept behind median. Now you must be thinking one question in your mind, that somehow median and median and mean are kind of similar concepts, but in which scenario do we use what? I will give you an example of what scenarios we do not use mean. The mean has one main disadvantage. It is a particularly susceptible to the influence of outliers. What if you have multiple staffs? Let's say staff number 1, 2, 3, 4, 5, 6 and so on. Now you have salary. So 15K, let's say 18K, let's say 16K, let's say 14K, let's say 90K, and let's say 95K. Now, the mean salary of these 6 people will be, if you try to calculate, the mean salary will be 15 plus 18 plus 16 plus 14 plus 185 is 248 divided by 6, which is 41K. Right? The mean is 41K. However, inspecting the raw data suggests that this mean value might not be the best way to accurately reflect the typical salary of a worker, right? Because if you analyze these 4 people, they are already in the range of 14 to 18. So this is not depicting the right numbers, because most of the people are within the range of 14 to 18K, right? The mean is being skewed by the too large salary. Now I used a term called as skewed. Well, we will be covering this topic in one of our future videos. Okay. Therefore, in this situation, we would like to have a better measure of central tendency. As we will find out later, taking the median is a better option. Now, what will be the median here in this case? If I sort the numbers 14, 15, 16, 18, 90, 95. So the middle value is these two. If I take a median, it will be 17 because the average is 17, right? Now this makes sense. If somebody asks you what is the median value, if you say 17K, it sounds okay because most of your employees are falling in the range of 14 to 18, right? So in these kind of scenarios, if you have outliers, in those cases, median is a better option to use. That's all about this particular session on median. In this video, we shall be talking about the third type of measure of central tendency, which is mode. What exactly is mode? The value which occur most frequently in the set of observation. Can have more than one mode, which is called as unimodal, bimodal, or multimodal. What are the steps to find the mode? It's very easy to find mode of any observation. Take the most frequent value present in the dataset. Special cases. If the maximum number of frequency repeated, if the maximum frequency is occurred at the beginning and end of the observation, if there is irregularities in the distribution. In all the above cases, we find the mode of the observation is using method of grouping. Let's try to understand using an example of where do we use mode. Mostly, mode is useful for categorical data. Imagine you have, again, I'll take an example. You are analyzing some customers' data. You have multiple columns. And one of these categorical columns is gender. Out of the 10,000 records or 1,000 records that you have, in this particular example, we'll take 5 records. Let's say one is male, null, female, female, female. So you have 5 records. Imagine you have 5 records. I cannot simply write down 1,000 records here. It is not possible. So example, we are taking 5 records. Let's say this is how the records looks like, and obviously you have one missing value. So what do you impute here? Idiotically, you cannot blindly impute male or female. Makes no sense, right? In this case, what we usually do is we find the mode here. As female occurrences are 3 and male occurrences is just 1, female becomes your mode. So a better value to impute here will be female. So this is one application of mode. This is where we use mode. But again, there are some drawbacks in the mode technique as well. What are the drawbacks? Simply try to understand this question, understand this scenario. Let's say you have 1,000 records. And out of that, let's say you are analyzing gender. Out of these 1,000 records, Imagine 200 records are null values or 200 gender records are null. Other than that, the 800 records that you have, let's say 640 are males and 160 are females. So what is the ratio here? The ratio here is almost 4 is to 1, right? 4 is to 1 ratio. Now, how do you impute these 200 records? The mode is very clear. The mode is male. But if you impute male in all the missing values, your ultimate records will be 840 male and 160 female. Now the ratio is changing from 4 is to 1 to 84 is to 16. Almost more than 5 is to 1 ratio, which is not in sync with the original distribution. So in these kind of scenarios, what we usually do is we try to maintain the ratio. The 200 records that we have, so what we will do is almost 160 records we will impute as male and 40 records we impute as female. But in certain scenarios where you have very less number of missing values, in that case you can also use mode. I hope everything is clear. These are all theoretical concepts. Once we jump into the practical sessions, once we jump into the EDA sessions, you will have better understanding, because we will be using some live data and we will be showing you different strategies of how do we use these concepts in real life. That's all about this topic on mode. See you in the next video. In the last video, we talked about measures of central tendency, where we understood the different concepts like mean, median, mode, and we also talked about various examples on where these concepts are going to be used. Well, in this video, we'll stick to the dispersion part in statistics. What exactly is dispersion? Dispersion is the state of getting dispersed or spread. Statistical dispersion means the extent to which numerical data is likely to vary about an average value. In other words, dispersion helps to understand the distribution of data. Now, measure of dispersion indicates that how the data is dispersed from the measure of central tendency. In statistics, the measures of dispersion helps to interpret the variability of data, that is to know how much homogeneous or heterogeneous the data is. In simple terms, it shows how squeezed or scattered the variable is. Now, let's try to understand the different types of measures of dispersion. The first one is range. It is simply the difference between the maximum value and minimum value. For an example, 1, 3, 5, 6 and 7. Here the range is 7 minus 1, which is 6. It is simply the difference between the maximum value and the minimum value. Second comes variance. Variance deduct the mean from each data in the dataset. Square each of them and add each square and finally divide them by the total number of values. Variance is basically termed as V, or else we can also term it as sigma square. What is sigma? We will try to understand it. Sigma square is nothing but summation of x minus mu square divided by n. Mathematically, we'll try to understand what exactly is this, but this is how the formula of variance is, where this particular symbol is nothing but which is summation. Here mu is nothing but the mean value. I hope everybody knows about mean, and x is your original attribute and n is the total number of entries. We also have interquartile range, which is called as IQR. Now this is nothing but Q3 minus Q1. What is Q3? Q3 is usually termed as the 75th percentile. Well, with examples, we have this particular topic covered in the future videos. and Q1 is nothing but your 25th percentile. We'll mathematically understand each one of them. And then comes standard deviation. Standard deviation is nothing but the square root of variance. As I have already mentioned here, variance is nothing but sigma square. Now this sigma is nothing but your standard deviation. The square root of variance is known as standard deviation. So if I talk about the mathematical formula of sigma, this becomes sum of x minus mu square divided by n root over. And then comes mean deviation. The average of numbers is known as the mean, right? Now how much deviation is having from a particular mean, that's basically your mean deviation. Again, we have it covered in our future slides, nothing to worry about. That's all about the basics of measures of dispersion. We'll have our concepts more clarified in the future videos. See you in the next video. And in this video, we shall be discussing the first measure of dispersion, which is range. Somehow we already understood what exactly is the meaning of range, which is the difference between your maximum value and the minimum value. This is one of the simplest measure of dispersion. It measures the difference between the highest value and the lowest value present in the dataset. It is used to construct control chart in quality assurance. It is also useful when you want to focus on extreme values of the dataset. Now what if you have a data? Obviously you will have multiple columns in it. Let's say one of these columns is age. What if somebody asks you, can you tell me what is the range of age? Which basically means what are the lowest values and what are the highest values? What is the difference between them? If the age starts from 18 and it goes till 90, then the range here is going to be 72, which is highest minus lowest. So the formula of range is very clear. Range is highest value minus lowest value. Talking about an example, let's say I have values like this. What will be the range here? The minimum value here is 1. The maximum value here is 7. So the range here is going to be 7 minus 1, which is 6. That's all about this video on range. In the next videos, we shall be talking about the other dispersion techniques. In this video, we shall be talking about the interquartile range, IQR. This is another measures of dispersion technique. But what exactly is this? This basically measures the middle 50% of the data. So interquartile range is a measure of where the middle 50% of the data is. Where a range is a measure of where the beginning and the end are in a set. We already covered range in the previous video. What is the minimum value and the maximum value? That gives you a range of the data. But IQR gives you the range of your middle 50%. So IQR formula is simply Q3 minus Q1. We'll try to understand what this Q3 and what this Q1 means using an example. This indicates how the data is dispersed around the mean. It is usually the difference between the third quartile and first quartile value of the dataset. It is helpful to detect the outlier present in the dataset. Formula is clear, Q3 minus Q1, but let's try to understand how do we calculate Q3 and Q1. Let me start with an example. Let's say I have an example and I have numbers like 1, 2, 5, 6, 7, 12, 9, 15, 18, 19 and 27. Now simply if you want to find the median, let's say we want to find the median, the first thing that we need to do is going to be calculating the median, right? So we have to sort these values first. How do we sort these values? 1, 2, 5, 6, 7, 9, 12, 15, 18, 19 and 27. So what will be the median here? The median is here going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 means 11 plus 2 by 11 plus 1 by 2, which is the sixth position. So 1, 2, 3, 4, 5, 6. So 9 becomes your median. Now let's try to place some parentheses here. So 9 is your median value, right? The median value. So median helps you to spot your Q1 and Q3 easily, right? Now, how do we find Q1 and Q3? Think of Q1 as a median in the lower half and think of Q3 as a median in your upper half. So what will be the median here? The median here is going to be 5 and the median here is going to be 18. Now if you subtract 18 minus 5, which makes it 13, that is basically your IQR. Now what if you have an even set of numbers? We'll try to take another example here. Let's say we have even set of numbers. Let's say 3, 5, 7, 8, 9, 11, 15, 16. How much? 1, 2, 3, 4, 5, 6, 7, 8. Let's say we'll take two more numbers, 20 and 21. They're already sorted. Now make a mark in the center of the data. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So somewhere here, right? Place the parenthesis around the numbers above. So the parenthesis comes here. Now what will be my Q1 value here? The Q1 value will be 7. The Q3 value will be 16. Now what will be Q3 minus Q1, which becomes 16 minus 7, which becomes 9. So 9 is basically your IQR. Now I hope that you got a fair amount of understanding about IQR, which is Q3 minus Q1. So be it odd number of values or even number of values, identifying Q3 and Q1 is very simple, and just subtract Q3 minus Q1, which will give you IQR. That's all about this particular video. In the next video, we shall be talking about some other measures of dispersion. See you in the next video. And in this video, we shall be talking about our next measure of dispersions, which is variance and standard deviation. We are going to cover both these topics in this video because they are related to each other, mathematically and conceptually. Now, what exactly is variance? Simply, variance is a type of dispersion technique. Measures the dispersion of the data around the mean of the data. It indicates how the data is dispersed from its mean value. If the value of variance is low, that means it is closer to the mean value. So it's called as low variance. That means if the variance is closer to the mean value, which is called as a low variance scenario. If there is significant difference in the value from the mean, then it is called as high variance. Variance is often denoted by V, or we also denote it using sigma square. This is basically sigma, which is otherwise called as standard deviation. What exactly is standard deviation? Standard deviation is one of the most important and frequently used method of dispersion. It is simply the square root of variance. It indicates how far away the data points are dispersed from the mean, and it is denoted by sigma. Now, talking about the mathematical formula, this is how variance is denoted, and the formula is like this. If I simplify it, it is nothing but sigma square is the summation of xi minus mu square divided by n, where mu is nothing but your mean value, n is nothing but your number of parameters. Now this particular formula changes from n to n minus 1 if you are dealing with a sample. So in short, when you are dealing with population, the value is n. when you are dealing with sample, the 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 formula is n minus 1. Now let's try to take some examples and try to solve the variance. And same goes with standard deviation as well. Standard deviation is nothing but summation of xi minus mu square by n root over. So let's try to take some examples and try to understand what will be the formula of each one of them, as in using formulas, what will be the values. Let's say I have some numbers 1, 3, 5, 5, 6, 7, 9 and 10. What will be the mean value here? That means mu. The mean will be 1 plus 3 plus 5 plus 5 plus 6 plus 7 plus 9 plus 10 divided by 1, 2, 3, 4, 5, 6, 7, 8. Simple. Which will be 4, 5, 9, 14, 20, 27, 36, 46 by 8. 46 by 8 will be around 5.4075. 4607, 4820. Yeah, around 5.75. Let's try to validate it. 46 divided by 8. Yes, it is 5.75. Now this becomes my mean. Now, as we already know the formula, so this is my x. Let's say 1, 3, 5, 5, 6, 7, 9 and 10. My mean is 5.75. So while calculate the numerator first. So xi minus mean. That means 1 minus mean, which is minus 4.75, minus 2.75, minus 0.75, minus 0.75, 0.25, 1.25, 3.25, 4.25. Now I will calculate xi minus mean square. So these individual square values. What will be the square values? You can simply take a calculator and try to calculate it. 4.75 multiplied with 4.75, it is 22.56. 22.56. 2.75 multiplied with 2.75, it is 7.56. See, irrespective of the number being negative or positive, the square of that number is always positive, right? Similarly, we'll have 0.56. We'll also have 0.56. This will be 0.06, 0.0625 in short. This will again be around 1.25, 1.56. This will be 10.56 and this will be 18.06. Now what I will do is summation of xi minus mu square by n. We are calculating variance first. So my numerator will be sum of all these values. So we'll try to sum all these values. If you sum it up, the values will be, let's try to use a calculator, 22.56 plus 7.56 plus this plus this plus this plus this plus this should be around 61.5. Let's try to validate it. 22.56 plus 7.56 plus 0.56 plus 0.56 plus 1.56 plus 10.56 plus 18.506, 62.4. One second, let me just do it again. 22.56 plus 7.56 plus 0.56 plus 0.56 plus 0.06 plus 1.56 plus 10.56 plus 18.06, somewhere around 61.48. I have just rounded it up to 61.5. Now how many attributes do we have? 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. This becomes 61.5 divided by 8, which becomes 7.68. If you round it off, it will be 7.69, around 7.69. Now this is your variance, right? Now what is the mean? You can see the mean is 5.75 and the variance is 7.69. That means the variance is almost very close to the mean, like the difference is less than 2, right? So it could be treated as low variance, but again, these are very few records we have. In real scenarios, when we analyze with thousands and thousands of records, that give us more idea, right? So here my variance is 7.69. So what will be my standard deviation? This will be the square root of this 7.69, which will be, let's take an example, let's take help from the calculator. It is 2.77. Now this becomes my standard deviation. So that is all about variance and standard deviation, very similar to each other. I hope everybody is clear about the definition point of view and from the mathematical point of view, right? Now, if these 10 records are not a part of your population and if they are part of your sample data, in that case your variance, which is sigma square, becomes, basically we do not consider it as sigma square. In case of sample, we consider it as S, which is, this is just a change in symbol, that's it. It is still the variance. This particular S is still the standard deviation, but it is the standard deviation of sample data, right? So this is nothing but 61.5 divided by 7. Whatever the values are, 61.5 divided by 7, which is 8.78. Now what will be the standard deviation here? Root of 8.78, which is going to be 2.96. Okay, so try to memorize this thing. In case of population, it is always divided by n, and in case of sample, it is always divided by n minus 1. That's all about this particular video on standard deviation and variance. In the next video, we shall be talking about some other topics. See you in the next video. In this video, we shall be talking about mean deviation. What exactly is mean deviation? Simply, we could already guess what could be the meaning of this. Mean is definitely understood. Mean is the average of a set of numbers. And deviation somehow gives me an intuition that how deviated these values are from the mean value, right? So the definition of mean deviation is very clear. It is the average sum of the absolute values of the deviation from any arbitrary values, example mean, median or mode, etc. It is suggested to calculate from median because it gives us the least value when measured from the median. Talking about the formula, this is how the formula looks like. It is summation of xi minus mu divided by n, and the numerator has an absolute value. What do you mean by this absolute value? Absolute value is simply nothing but, let's say we talk about a number minus 5. The absolute value is 5. We do not worry about the minus or plus attribute of it. Be it 5 or minus 5, the absolute value is always going to be 5. It is always positive number. Now let's try to take a small example. Let's say we have 4 people. Let's say Jennifer. Let's say my name, Sat, Amelia, Oscar. These are the 4 people. Now, and one more person, maybe Mr. X or could be James, right? Now, Jennifer has 4 apples. I have 3 apples. Amelia has 3 apples. Oscar has 2 apples. And James has 5 apples. The question here is find the mean deviation of the data. Now, if you start adding the mean value, let's try to calculate the mean value. The mean value will be 4 plus 3 plus 3 plus 2 plus 5 divided by 5. It is 4 plus 3 is 7 plus 3 10 plus 2 12 plus 5 17 by 5, which is 3.4. So the mean value is 3.4. Now what will be the x minus mean value? Let me just draw it again. 4, 3, 3, 2 and 5. So what will be x minus mu value? Imagine mu value is 3.4. We don't have to imagine, we already know. So the first value is going to be 0.6 minus 0.4 minus 0.4 minus 1.4, 1.6. So 0.6 minus 0.4 minus 0.4 minus 1.4, 1.6. What will be the absolute value? All the positive numbers. 0.4, 0.4, 1.4 and 1.6. Now if I have to add this part, which is this numerical part, sum of all the absolute values. So this is going to be 0.6 plus 0.4 is 1, 1.4, 1.4 plus 3, which is 4.4. 4.4 is going to be your numerator value. So what is my mean deviation? It's going to be 4.4 divided by 5, which will be 0.840, 0.8. So it's going to be 0.88. So the mean deviation is going to be 0.88. So that's how mathematically we understand the mean deviation part. That's all about this particular video. In the next video, we shall be talking about the next topics. See you in the next video.